Hello, and welcome to the CGCookie.com tutorial. My name is Kernon Dillon, and this is part 2 of the Magic Wand Particles Effect tutorial. And in this part, we're going to take a look at creating the particles system that will be used with the sprites that we created in part 1. So let's get started. Okay, let's begin by setting up our environment for the particles. Let's delete the default cube. And let's add an icosphere, and we'll use the default settings, and then scale it down. And now we want to add a camera, and then let's just position the camera. I'm going to move it back and then rotate it 90 degrees. Okay, and then I will apply the scale and rotation so that resets those values to 0. Alright, now this camera is not the active camera, you can tell by the empty triangle, so let's press Ctrl 0. That makes it the active camera, and it takes you to the camera view. And I'm shift selecting the emitter object and then moving them both up along the Z-axis by pressing G and then Z. And that's just what I prefer. And let's position this off camera a little bit. Okay, now we want to add a curve, a path curve. And I like using path type curves because it's just easier to get the shape that you want for certain things, certainly for what we're going to be doing here. And you just tap into edit mode just like with a mesh to move the control points around. And I rotated this along the x-axis 90 degrees and then applied the scale and rotation for that. Okay, then we tab into edit mode and we're just going to move these control points around to get the shape that we want. And this will be the path that the emitter will follow, and we'll apply particles to the path. To the actual emitter object. And we just drag these around, and when you want to extend it, you just select the last control point and Control left click to extrude new vertices. And then we'll reshape that. And this is a lot easier than dealing with a Bezier curve where you have handles and you've got 3 different points just to control any one aspect of the curve. And so for stuff like this, I really think this is just a lot cleaner and easier to get the shape that you want. Okay. And now we want to have our emitter move along this curve, and so we need to get it to the starting point of the curve. So we tab into edit mode of the curve and select the first control vertex and press Shift S and snap the cursor to that point. And then we select the emitter object and press Shift S and snap the selected object to the cursor. And now we have our emitter object at the starting point of the curve. Now let's shift select the curve so we have them both selected, and then press Ctrl P and select follow path. And then when we press Alt A to animate, we see that our emitter object moves along the curve. Okay. And let's split a window here. And let's split another window and add a timeline. We'll change this window type to timeline. And that's so we can scrub along and control the point in the animation that we're looking at. Now you can see as we scrub along here, our emitter object is actually rotating. It's following the actual tilt of the curve as it moves along the path. And we don't want that. We want it to maintain its initial orientation as it moves along the curve. So select the curve, go to the editing buttons window, and disable curve follow. And it will still go along the path, it just won't follow the actual tilt of the curve. And so we maintain the same orientation from beginning to end. And let's see. If we animate, we can see that the animation speeds up and slows down. It speeds up in the middle and it comes in slowly and slows down at the end. So let's open up an IPO curve editor, and with the curve selected, let's change the curve type, the IPO type, to path. And we can see that we have a speed curve that's automatically attached to any path. And we can see that it's not a straight line. It comes in slowly, and then it speeds up, and then it slows down again. And so we want to make this a straight line, so we press T and select linear to change the type to linear so that the rate of change is constant. And then we want it to have this curve remain constant forever. So we want to extend the beginning and the end of it. So we press the E key for extend mode and select extrapolation. And now our curve is a straight line that has a rate of change that's constant. And now our emitter object will animate at a constant speed. Now, just as with meshes, we have an object, and in edit mode, the object mode, you'll see curve on the header bar, and you tab into edit mode, you'll see point. And that way we can select points along this curve and move them around. And the current setup we have now, the slope of the line will determine the rate of change, which will determine the speed of the emitter along the path. So a flatter line will give us a slower speed, and a steeper line will give us a faster speed. Okay, and that's what we want. Now I'm looking at where this ends on the line. We can see that's frame 25. And so we'll make the length of the animation 25 frames. Well, we'll make it 30 frames, so it's a little bit longer. And then let's press Alt-A. Okay. So we don't have all the extra frames at the end. And I think I want to slow this down just a little bit. And doing this is going to adjust the end, the point in time where the emitter object ends on this curve. And so we'll need to adjust the length of our animation. We can see that now it ends at the 35th frame. So let's make the length of the animation 40 frames. Okay. And let's see, we'll move this out of the way for now. And now, since we're dealing with a curve and we're going to be dealing with particles, we need to save our file so that when we have cached data for the particle simulation, it'll know where to put those files, and we want them right next to our actual blend file so that everything is nice and organized. So we'll save the blend file. And now we're ready to set up the actual particles on our emitter. Okay, before we go any further, I think I want to scale down this emitter object. It's a little bit too big. And so we get a better view of the keyframes in the timeline. Let's set it to view all, or you can press the home key, and that scales everything so you can see it nicely fitted inside the timeline window. And let's save the file. And then let's go to the object buttons window. And with our emitter object selected, let's change the name to something a little more meaningful. We'll just call it emitter. And then go to the particle subcontext and click on the Add New button. And this will add a new particle system to the object. And we'll call it Magic. And let's set the amount of particles to 500. And we need some velocity so that the particles have some speed as they're emitted. When we press Alt-A, we can see the animation. And now they're not coming out in a good way. So let's set the emission to random among the faces and even distribution. Okay. And we can see that the particles will stop emitting at frame 100. Now let's figure out exactly where we want them to stop emitting. Right before the end, so that we don't have a big clump of particles at the end. And we see that's frame 34. So we set the end time to frame 34. And we go back to the beginning and animate and see that they stop emitting at frame 34. Okay. And let's use continuous physics. And what that will allow us to do is during playback, we will be able to see the physical aspects of the simulation while we change parameters. And that's pretty convenient because we can see everything while we make changes. And now they're coming out a little bit too far and too fast. And to dampen their distance of spread from the emitter, we can increase the damp value. And let's increase the number of particles to 700. Okay. And sometimes you'll have to pause continuous physics and reset it to go back to the beginning so that the particle system can reinitialize. And we see that the lifetime of the particles is 50. Let's give them a shorter lifespan. And we can see that's not quite enough. But if we pause the continuous physics and go back to the beginning, we see our effects. That's one of the parameters where you need to reinitialize the particle system in order to see it. So you just press pause and then the back button. Okay, and we can see that we need to increase the number of frames because we want to see all of our particles die out before the animation ends. And so we increase the length of the animation. And we want to randomize the lifespan of the particles so they don't all end in the exact reverse order in which they were created. So we don't have such a linear appearance to the actual disappearance of the particles. And if we randomize it, it looks a little bit more natural. So let's increase that even more. Okay. And let's see, let's give them a little bit more speed. And now they're all coming out at the same speed. So if we increase the random velocity, we'll get different speed values for the particles coming out, and that'll make them a little less uniform. And we can bake the particles, but you need to be careful to make sure that the end time for the bake is set to the same length of your actual animation, so you don't end up baking more frames that are in the actual animation. And after you bake, you can scrub along the timeline and see the effects of the particle simulation. And let's change the visualization to circle, because that better represents what our sprites are actually going to be, since they're mainly just round graphics that will be textured onto billboards. And let's see. And also note that when a particle system is baked, you can't change any of the values, so you have to go in and free the bake, and then you can go and adjust any of the values. And this brings up the issue of the convenience of using continuous physics, because you don't always have to deal with that issue. Now let's increase the amount to 800 particles. Okay. And let's turn up the Brownian motion so that this will give the particles a little bit of wiggle, so it adds a little bit more life to them, and I'll exaggerate it so you can see. Now these are really subtle movements, and you won't be able to see them in this video because of the frame rate, but the downloadable version of this tutorial is at a much higher frame rate, and you'll be able to see all those subtle movements. And let's increase the lifespan of the particles so we get a little bit longer tail. Okay, and now we want them to fall a little bit, so we increase the acceleration along the z-axis in the negative direction, and if we want them to go up a little bit, we set that value to positive. And I think I want them to fall down a little bit, so I'll make it a negative value. Okay. And let's change our visualization to Billboard. And this is the actual visualization that we're going to use in the final system. And so now we need to start being concerned about the look of these. So let's turn down the scale, the size rather, using the size parameter. And now they're all the same size, so we can use the random field right beneath that and increase that, and that will give us a greater range of sizes relative to the size value that we set in the field above it. And you can see we have a range of sizes, but none of them are larger than the actual value that we have in the size field. And if you set it to 1, then you're going to get a range from very small all the way up to your actual size that you have set in the parameters. And that's a little bit too small, so I think I will turn that down, turn the random value down. I'll free the bake. Let's turn that down a little bit. Okay. Let's make them a little bit smaller. Okay, now we have a good range of sizes. And I'm going to let this animate through and then pause it. And we can see that we're not getting any rotations. And we can control the rotation using the tilt parameter for the billboards. But we want to animate this. So let's go to the IPO window and make sure our emitter is selected. And let's change the IPO type to particles. And we can see that there's a BB tilt channel, and that corresponds to the tilt parameter. And so we go back to frame 1 and we control left mouse button to set a keyframe. And then let's do another one at an arbitrary point further down in the frames. And if we animate this, we can see that, well, it's only rotating right at the end. So we want a constant rotation, so we need to change our curve. And so with the curve selected, press the T key and select linear, and then press the E key to set the extend mode to extrapolation. And this is the same thing we did for the speed curve for the actual path. And I've selected the first vertex and brought up the properties panel with the N key, and I'm just setting its values to 0, 0, so it's exactly at the beginning of the animation. And as before, we can change the angle of this curve and control the speed of the rotation. And right now they're rotating counterclockwise, and we want them to rotate clockwise, so we bring the curve so that it slopes downward, and now we have our clockwise rotation. Okay. Now another thing that we need to make note of is that they're all rotating at exactly the same rate and the same, or at the same angle, the same starting rotation. And so the rotations are perfectly aligned, and we don't want that. So let's see how we can get the rotations to be random. And the way we want to do that is to use the random feature in the visualization panel that will allow us to randomize the tilt of the billboards. And so we increase that value, and we can see that we're now starting to get random offsets on the rotations of each billboard. Okay, and that's going to make it look a little bit more lively so that everything isn't parallel when we have the actual sprites mapped onto each billboard. Okay. All right, and let's go back to the circle visualization. And we're just looking things over, and we can see that we use the circle visualization to allow us to control the actual physics and get the dispersion of the particles the way we want them. And then we switched to the Billboard visualization so we can see the actual planes that our sprites are going to be mapped to, so we can get the rotation and things like that in place. So it's a good example of how you can use the visualizations to get different views of the particles and take advantage of what each one has to offer. And you can do all this without having to actually have your sprites in place. And so it's really good for developing generic particle systems. Okay. And that's about it. In the next and final part in the series, we're going to take a look at how we can add the sprites to the particles and work towards our final effect. So I hope to see you there, and thanks for watching.